the greatest scientists who ever lived. He spent the majority of his early adult life locked inside of his own house, isolated from most other people because there was a plague roaming around Europe at that time. Now, that may sound a little too familiar and a little too close to home for you at the moment, but he did come up with some of the most important ideas that we use in science during this time. He came up with laws of motion. He came up with ideas about light, and he came up with ideas about gravity. But he also was able to recognize something important about his work. He's quoted as saying, "If I have seen further than others, it is by standing on the shoulders of giants." And this is an important thing to recognize about science, is that science isn't about one individual. It's actually a culmination of work over time. The scientific ideas that we have today are based on the work of people from hundreds of years ago. And even though they may not have had the correct ideas at the time, we now have a much better understanding of the world around us because of what they discovered. And I think this speaks to a really important thing about science, is that we're not afraid to admit when we're wrong. But science doesn't just admit when they're wrong because somebody said so. You know, when somebody comes along with their YouTube research and tells you that your scientific ideas are incorrect, that's not really good enough. Science is based on empirical evidence, and if you collect empirical evidence that has been reviewed and checked and studied, and that disagrees with the current understanding that we have today, then we reformulate our ideas to make that new evidence fit. And this is an important thing. Science has to be able to actually change. And I think there's no better demonstration of this than one particular scientific idea called atomic theory. Now, atomic theory is the theory of the atom. And it is so important to our life that it's used to help us build materials, to understand the world around us, and to actually figure out what things are made out of. You also may not have even thought about it as a theory. And that's because a lot of people think about a scientific theory as something different from what it really is. A lot of people think about a scientific theory as being the same as when they say, "Hey, I've got a theory about that." When you say that, you actually are talking about having a guess, a hypothesis, an untested idea. But in science, a theory is highly tested. And it's important to recognize there are different ways of categorizing scientific ideas. There are scientific laws. A good example would be the law of gravity. The law of gravity states that any two objects that have mass will be attracted to each other. It actually even has a formula, a mathematical equation, to help us understand this. But nowhere in that equation does it describe why. There is no discussion from Isaac Newton about why different objects actually come together through the force of gravity. Instead, he just explained what you were going to see, and that's what a scientific law does. On the other hand, a scientific theory explains why we actually see what we do. To give you an example related to gravity, Einstein came up with a theory of special relativity, and that theory actually helped us understand the way that the universe bends and reshapes in order to actually have objects with mass attract each other. It was the first time that anybody actually had evidence to support an idea about why gravity works exactly the way that it does. And when we talk about the theory of the atom, it also is explaining why. So the theory of the atom is explaining why is the world the way that it is? Why are materials made up the way that they are? Why does stuff behave the way that it does? Really, it's why do things do what they do? And that may sound really undescriptive, but that's what atomic theory is about. Atomic theory is about trying to describe the physical world and describing all of the stuff that it is made out of. In order to understand this idea and its development through time, like we usually do in science, we're going to talk about some old Greek guy. Okay, We're going to be starting by talking about Democritus. So Democritus was a philosopher. So he was trying to find truth and question ideas. And he was really dealing with one problem in particular that we know of. And we're going to take a look at it by talking about one thought experiment that he ran. This is what we call the cutting thought experiment. So a lot of people talk about this with an apple, but let's think about something more delicious. We're going to talk about a block of cheese. Imagine you have a block of cheese, and you cut that block of cheese in half. Then you take your half a block of cheese, and you cut it in half. And now you're down to a quarter of a block of cheese. So then you cut it in half, and then cut that half in half, and continue to cut it in half over and over and over again. And Democritus's question was, if I do this, is there going to be a point when I can no longer continue to cut? And I know what you may be thinking. You may be thinking like, well, yeah, the knife is just never, it's going to be too big at some point. It's not going to be able to cut through it. But Democritus went even further to say things like, well, what if the knife wasn't the limit? What if I could get smaller and smaller knives? And I could just continue to chop. Is there just going to be a point when it is no longer able to be divided? Well, you may recognize this as kind of a mathematical problem of dividing by 2 or dividing in half. You see, mathematically, if you divide something in half an infinite number of times, you never get to 0. And this is what led Democritus to this idea that there is something that is uncuttable. And the Greek word for uncuttable is atomos, which is now where we get the idea of the atom. Okay, I know, don't make fun of my graphics here. I don't have like a graphics team. That's the best I could do. I'm working with like PowerPoint, so just give me a break, okay? It's fine. It's good enough. You get the idea. It's uncuttable. Now, I think a lot of the time we end up talking about these ideas and we make the leap from some Greek philosopher, usually to Aristotle, and then to somebody who was living in Europe in the 17 or 1800s. And we kind of forget about the rest of the world. And I think it's important to recognize that this is a question that other people in other places in the world were asking. Because the question is, what is the world made out of? And we may not have records or ideas about some of those conversations or those philosophical discussions, but we do have one for sure. And it comes from someone on the Indian subcontinent named Kannada. And he actually was asking pretty much the exact same question. And he also independently came up with the idea of an uncuttable thing, which we would also understand to be similar to the atom. Now, their ideas may not have been fully correct. You see, Democritus's idea, he actually thought that the atoms had structures that led to their properties. To give you an example, he thought water atoms were smooth and slippery. He thought that iron atoms were hard and blocky and stacked together. He thought fire atoms were full of little spikes that hurt you when they ran into you. And so different cultures came up with different ideas about what the material world was made out of, and they used their observations to try and make sense of them. But ultimately, their ideas tended not to be fully accepted. Instead, the idea that became quite heavily accepted came from, yeah, you guessed it, Aristotle. Aristotle, or as I like to call him, the king of the wrong ideas, had his own thoughts about the material world. And if you are familiar with Avatar: The Last Airbender, you probably have a pretty good idea what this is. He thought the Earth was made out of 4 different materials: fire, water, earth, and air. And those 4 materials came in different combinations and created the different things that we see. And so ultimately that was where stuff came from. And this was an idea that became very heavily accepted for a very, very long time. And a big part of this is because Aristotle was a very respected philosopher, but there wasn't really anybody doing science about this at the time. So maybe it's important to recognize, what's the difference here? What is the difference between philosophy and science? Well, the difference is really evidence. You see, philosophy is the study of truth by using logic to try and reach truth, whereas science is the study of our natural world and trying to understand it through empirical observations and evidence collection. They are both trying to arrive at an idea about what does it mean to, or what is our world like, what is true, but science really is limited to only collecting evidence. And you may wonder, well, why didn't they collect evidence when they were philosophers? Well, a big part of this was they were limited by technology. There just wasn't things good enough to cut small enough, to analyze, to check and see what was going on. And so we kind of had to wait for technology to catch up in order to explain what the material world was made out of. Okay, so we're going to jump forward pretty far in time here, because we need to get to a point where technology has caught up for people to actually understand the material world. So we're going to jump forward to about 1800, just a quick, 2,500 years. And we're going to talk about one scientist in particular, but it's important to recognize at this time, people knew that there were certain elements that couldn't be broken down any further, and that the amount of substances didn't change as they went through chemical reactions. And this scientist, whose name was John Dalton, actually dealt with these ideas. John Dalton may be one of the most boring sounding people in history. He was a chemistry teacher, but don't hold that against him, okay? But he also studied the weather, and he went out every day to the same spot on the same hill and brought the same notebook to write down exactly what the weather conditions were like every single day. Yeah, I know. But that's what he did. That's what he was interested in. So, you know what? Go for it, John. But John Dalton gave us the first atomic theory because he was analyzing gases. And he used those gases to help him understand ratios and do some complicated experiments that ultimately led to him publishing the first known atomic theory. Now, his atomic theory we're going to look at has 5 major points. These were the 5 major points. So number 1, all elements, all things that can't be broken down any further, were made of extremely small particles that he called atoms. All atoms of the same element were the same size, mass, and had the same properties. So what he meant by that is every gold atom was exactly the same. If you had one gold atom and another gold atom, you literally could not distinguish them apart from each other. They would be identical in every way. He said that iron atoms would all be the same as other iron atoms, but iron and gold atoms would be different. He did recognize that different elements had to have different atoms. The next thing that he said is that atoms cannot be broken apart. They were the smallest things that existed, and those elements combined in whole number ratios to make things called compounds. So that's how we got things like carbon dioxide and nitrogen oxide and nitrogen dioxide and all of these different things. And he said that this recombination took place during a chemical reaction. His idea was actually based on evidence and became accepted over time as the way that matter was built. But you may think there's a lot of things in here that sound correct. There are a few things that you know now may not be totally correct, but just to give you an idea, he wasn't totally all with it when it came to the structure of the atom. I mean, he did make some great leaps and bounds, but he was limited by the evidence that he could collect. So he thought that atoms connected together because they had little hooks on them. And those little hooks grabbed onto each other and ultimately led to the reformation of different compounds. And he said different elements had different numbers of hooks, and that's why they tended to form the same compounds over and over again. Seems like a reasonable idea until you actually get some more information about the atom. And that's what we're going to take a look at in our next video, is somebody who took these experiments even further to understand a deeper structure of the atom. So thanks for watching, and I'll see you next time.